Hi everyone, welcome to Coding Bytes. I'm going to try and take it a little bit easy with my throat today because I am suffering. I wanted to get this video out there. If it gets too bad, I will remake it. But slightly different topic today. I'm actually going to look at a problem that someone's having online and just see if I can apply object-oriented programming to solve it or to come up with a solution. Ultimately. So I'm a member of SASE. If you're not already, I highly recommend you joining, and it gives you access to the Slack channel. And what came up on one of the threads, Josh put out a question just asking, curious to see how other people would solve an issue that he's run into, or like, not really an issue, it's a solution, it works. But it takes manipulation of the language. He can tell that there's some issues with it. So obviously putting the question out there, how would other people solve it? I only program object-oriented programming in PLCs. So my take on almost every problem is use an object, and I put that out there and just said, oh yeah, have you considered object-oriented programming to solve this and make this problem an object problem, and then you'll have an object solution. So what I wanted to do, he asked me to just elaborate, so I thought I'll put just together a little video of it. So just as a way of not having to type out a load of things in reply, but also just so you can see how my mind works when I come to tackle these type of problems. So the issue that I believe Josh is having is he has function blocks. These function blocks have got methods upon them in which they're being called something along the lines of stopping, resetting. There's clearly something behind the scenes that is invoking these methods upon this function block. But inside of the function block, he has a case statement, and he's using do step, which is returning an enumeration. And then what he's allowed to do is pick and choose which of the enumerations this function block will respond to. So what you can see here, enumeration of substates, init, axis power, axis stop. And you can see the method in here is calling do step. If .init is returned, it requests a next step, and also as well, if it's in axis stop, then it will perform some sort of function. I don't know deep down what's actually occurring in here, and passes back something along the lines of sequence complete. So you can see here, had do step been called and axis power was returned, this method would do nothing. Seems fine. That's all good. So far so good. I think the problem arises. Sorry, I was hoping that would go to a different one then. The problem arises is they're using the enumeration, from what I believe, to control the sequence of events, and therefore this enumeration is made its way down through the enumerations, and all modules receive the same enumeration, and therefore it's only when the modules are given enumerations that they know to look for will they act upon it. And as you can see here, these substates, type substates, so again, if you've got more than two type substates, they're going to clash with each other. So because you've already defined your enumeration at the end of the day, adding something like cylinder power in here, that may mean that he's got a cylinder module that will respond to init and maybe cylinder power, that type of thing. So the issue I believe they're facing is they define modules, they determine what enumeration states that these things will actually do something with, and when they combine the whole thing into one big project, they end up with a very application-specific set of steps. They then need to modify the enumeration to be the application's enumeration that contains all of the states in the correct order that this thing will progress through. I hope I've got that right. So that that sets the scene of the problem I'm going to look to tackle. So I look at this and think, let's just use objects. And what I'll do is I'll just show you how I go about doing that. So, and again, apologies for my voice at the moment. Right, so let's get started. So the first things first, I'll just add in, just straight in with a method. I'm just going to start, I'll run through just the way my mind's going to work. I haven't constructed this in advance. I'm going to do it now. So I believe there is a thing which is at the end of the day, it's going to be a state. We can, or it's, what do we call it? Let's see again, this way it goes, substates. So substate, I'm just going to call it as it is. So it's a sub state. There we go. So I'm going to make a function block called substate, which is fine, because it just gives me a base to work from. Whether or not I use inheritance, probably in this instance here, but we'll just build it up as we go. So this thing's going to have substate, and the other thing as well, so when people receive, so in other words, the function block, let's say for example we're going to do a motor function block, and we'll start with a simple one. Let's start with the init substate. This function block will receive something that when it calls do step, it should return something that it believes is the init substate. So that's what we're going to try and focus on to start with. So as with everything I do when it comes to object-oriented programming, this is going to be my object. This is probably going to be the parent class, because I believe I'm going to inherit from this, because all my states will potentially inherit from it. I may not, because the thing is if it's not complicated, if you're not doing a huge amount of things in your class, don't worry about doing inheritance. Just make an interface and let everyone inherit that interface, and then just do your job in there, that type of thing. So we'll see. But I tend to start with potentially a base, like a parent. We see how it goes. So the second thing I'm going to do is I'm going to add an interface, and I'm going to call it I substate. Oh, substate. Nice. Because typically you'll find an interface will match like a parent name quite often, because then as the children all span out and go, oh, I've got an init substate, they naturally inherit the I substate interface. Good. So the substate itself, I'm going to go down the route of, because potentially I'm going to receive this substate, and I need to know, is this the substate that is for me, that I react upon? So what I have in my mind is that the motor class will have its own copy of an init substate. When the object comes in, which will now be an object version of a substate, it will say, oh, I've just received a substate. Are you the same? It'll actually use the substates themselves to compare themselves and say, are you the same as the thing that I'm currently holding? As in, I hold an init substate, which I'm going to react upon. Are you the same? Excuse me. Okay, right. That'll probably end up into sort of an if, else if, sort of, rather than a case statement. But by the by. Right, so that means I'm going to say is equal, and it's going to be Boolean, it's going to be public. This thing here, I'm going to say is equal to, I'm just going to call it substate, and it's going to be an I sub state. So I'm going to pass in a substate. I'm going to say, hey, you as a substate, I'm going to pass you a substate, and can you tell me if you're equal to each other? What's nice about this is it means that you can you can expand what a substate uses to tell if they are equal in the future, and then you're using code. The code that is using these won't care about that. They'll still call upon it is equal. You're not making it the task of the person using the substate to be able to determine are they equal or not. The substates do it themselves. So I need some form of way of telling what the substate is and actually is. So I'll use that as a property, and we'll call it, so you don't need to prefix this with substate something, because it is a substate. So I will call this substate, let's think, it's a name. I might give it a name. We'll start easy. Substate name, you could say type, but type's a reserved word. We'll stick with name for the minute. Name's going to work. We'll just do tmax string. Okay, access specify public, done. Nice, get rid of that. So the other thing as well, there's an interesting video done by Christopher Aquavi. Sorry, again, this is a Coding Bytes video, so I digress. This is just where I put out information while I talk. So there was an interesting chat by Christopher Akravi. I highly recommend that you watch his channel. And it was about the dangers of, it wasn't inheritance. He said you don't need to make child classes if all they're doing is manipulate, just changing the data that's used inside of an object. So what do I mean by that? This thing here, I could reasonably say that my substate has nothing inside of it. That's okay. It's going to have some is equal code, and that is equal code. I mean, we can fill this in now. We can say my name, because I know I have a name, is equal to substate, the one that's been passed in, dot name at the end of the day. That doesn't show up there yet because I need to copy and paste that into the interface. So now at this point here, it knows that whoever gets passed in has got a name. We're good. And is equal is just purely going to be, and again, I'm doing assignments equals there. There we go. So for the minute, that's going to be more than enough to determine is the substate that I've actually just passed to you equal to the one that you currently hold, and all's good. I could, let's say, for example, we turn around and say this is my init substate. Init substate, which is fine. And we just okay that. This thing here could, and you would be tempted to, substate, extends substate. So you extend upon it, and we could say that the substate itself, this thing here, I forget what side it goes, abstract. Yeah, it goes on the other side, public abstract rather than abstract public. I could say I don't hold that in my substate. I don't hold that in this object, which means that this object would go abstract as well, which means you can't instantiate it. It means you have to inherit from it. And from this point here, what happens is it forces someone to implement the name property, because the minute I make something abstract, it says, I know it exists, but I don't implement it, which is why I'm allowed to use it here. Is equal equals name, substate name. This name, it has no code inside of it. The minute it goes abstract, there's no code inside of an abstract method or property, but the class knows it exists, therefore you can use it in its code. It just means that you have to play pass the parcel, let the child implement it. Is equal, however, isn't abstract, which means that this class doesn't need it because it naturally gets deferred. So if I instantiate an init substate, excuse me, one moment. If I instantiate an init substate, and just to show you this, and again, this is a little bit of a segue, but again, that's my video, sorry. Okay, so if I have an init substate, what we can actually see here is we still get is equal, because this one is inherited from this. Is equal is just naturally deferred back to the parent. And name, because this was marked as abstract, this must have it. If I was to remove that, I won't remove it, and do a build, it would say you can't do this because you need to resolve the abstract method or property. Someone, yeah, the parent said, no, I'm not doing it. The child must do it. This could be abstract too. We could play parcel. In the end, whoever is the last person must have resolved all of the abstract methods and properties. That's just the way it goes. So what I'm getting to is this. We could say, we'll just call it the init, and that's it. That's, long story short, what Christopher Akravi says don't do, because you're forcing people here. You're getting like a class explosion. It's not a class explosion, but you're forcing people to go down the inheritance route to define something that only the name is changing. Instead, you should pass that to a constructor, because that's the only thing that's changed. So showing you the, say, correct version is, I mean, you can do this, but I wouldn't. I tend to make a constructor folder just to keep things tidy, add fb init, It fills it all out for you. This thing here, I would then say, what is the name at the end of the day? Because again, I can instantiate it with a name. There we go. I run straight into my first. Yeah, there we go. This is live coding. So we will need to do the class explosion, because it's all well and good having a parent that can be instantiated with it, but we want commonality. We want like the enumerations. We want this predefined. We don't want people changing what's inside there. I want to instantiate something and it be set for me. So just following that round. Originally I was thinking in my head, right, that's all right. I can just pass in when I construct. Again, that's I would have passed in a name. I would have made name equal. I would have had a private variable, pass the name in. But that means anytime you instantiate a substate, you yourself are responsible for telling it what it is. We don't really want that. We want to actually have a library of defined substates that people can rely on in the future. So yes, we are going down the inheritance route, and we are going to force people to make individual versions of this, which is fine. That's all good. That's all good. Nice. All right. So I hope that's clear. If that doesn't make any sense, let me know. But we'll progress this way, because this is actually the way it's going to be. So it still feels okay having inheritance, because is equal is some code. Had we not done inheritance and we just say no, the I substate, again, need to copy this one up as well. If you're a substate, you need to have this is equal method too. So it's just one of those things. You need to implement that. Had we not done inheritance, it means I would have forced this one and every subsequent one. I mean, let's just do another one as well. I'm actually going to make some folders just so this looks a bit tidier. So substate. So that's the substate. That's going to be my next one. And I tend to get a little bit folder happy, to be honest. I make a base, and that's going to be in the base. I actually also make a folder called interfaces, and that's where that one will live. Nice. Okay. So if we go back to the original, init axis power, cylinder power. So init, we'll just go back to this. This one is going to be axis power. I won't do all, I probably will do all of them, but axis power, wowza, sorry, it's cold today, so my fingers are a bit slow. Nice. Okay, we can use exactly the same notation as well, axis power as what was originally used in the first example. Okay, so let's just tidy some of this up. Init substate, that's fine. And yeah, that was the end of that one. So file save, Control Shift B, and quick build. So no errors. Everything's looking good so far. So what does that mean for our side of things? So if we just go into main just to make sure, so we've got one of those. This one here. Nice. Let's just drop that in as well, just to prove that we've got something that's building. This will all resolve itself in the end, as in there is a plan, and this will actually hopefully resolve into the thing that you actually wanted in the first place. Nice. So that all builds as we expected. And what we can do as well is just do a small test and use TC unit. Test all the way. Yeah, I highly recommend it. I'd actually start writing tests already at this point. To test is my, where are we in a base? I would be testing is my equal working. Just one of those things. Because I'm going to write the test here already to see if it worked. Why not write that in a TC unit test? So this one in here, we can just say test is equal to the init substate dot is equal to this one here. So that should return false. And then what we'll do is we'll instantiate two of these. Substate 2, and we'll make this test. I don't usually do this as in stacked variables on the same line, but just for while we're doing this one, test 2 is equal to init substate test dot is equal to substate 2. Okay, nice. Cannot cover. So there we go. So the thing I've missed is in the base, the base, you may as well use the base because it means everyone inherits from this as well. We say implements I substate. Oops. Implements. Nice. Good. Move off the line. It gets bigger. Done. Just thinking like forwards. If you wanted to use a case statement for iterating over what state it is, instead of name, you could you could have a name and a sequence number. Whatever it is, you're going to get into a situation where you're going to need to make sure you don't clash, because someone making a library somewhere else might define a substate, and if that substate clashes name with someone else's substate that's been developing a library in isolation, you're going to have issues. But anyway, so we'll keep heading down this route. Okay, so that should now build. So just build that, make sure it actually works. So we'll log in. Nice. Okay, so this one says it is equal, the other one says it's not equal. So that's exactly what we'd expect. That would be a TC unit test. Every time I build and run, I would see the test is passing. I move on. So because I just start building things up as I go. Next. So the next thing that we want to do with this substate, this notion of substates, is there will be some form of object which is passed in, and to the thing that wants to receive these substates. I'm not going to pass these substates in directly. I'm going to pass in an object that holds the current substate, because then it can do things like that whole do step. It can call upon do step on the thing that's holding the substates, and it will return out the current substate. So that's definitely going to be something that I'm going to make as well. So as in just a notion of it, it's going to be, and I'm going to call it, let's have a little look, because that was also mentioned, the thing here with the application library. So I'm going to use terminology, which is the same. So yeah, application substates. Yeah, application substate. I'm going to call it the application substate because it will hold states, but it will show the current state. So this one here, application substate. BICATION substate. So this one here, nice. Right. So application substate. This thing here will have initial and again, it's an internal variable, so it's lowercase, initial substate. So I know that this thing's going to have an initial substate that will be given to it, and then it will have a current substate, which will be the one that is currently active. Because I also get this feeling from the current example that there will be a notion of let's roll back, let's go back to what it was. We could even support go back, go next, that type of thing. That's all going to be possible. This thing is a substate. Again, we don't know who we have been given, but we will hold it. And which means I'm going to use a constructor for doing this. And this thing's going to have FB method, which is FB init, open, and I'm just going to call it the same. Initial substate, and it's going to be an I substate. Done. And because the variable is called the same thing, if it was called different things, let's just show you that to start with. So substated, you can do this. That's completely fine because the compiler knows how to resolve that. It says, yeah, that's different, that must be the one I'm holding low, that is in my private variables. This one is this one here. When they're called the same thing, the compiler can't work that out. So it's impossible for it to do. So if I was to do this, because it's not case sensitive, this would actually write the variable here back into itself. So you need to be explicit at this point and say this hat dot. So this hat is the pointer of the current class. So this is the pointer of the current class. The hat dereferences it. And the dot means you now get access to all of its methods and properties and internal variables as well, because that's one of those things you're allowed to do that as a class. Nice, so that's good. Let's start building this up as well, because this is slowly starting to take shape. So this is going to be my application state, and it's going to be application state. That actually has to go underneath, because we need to pass it things that we've actually defined. And I'm just going to call it the init substate. Is going to be the first, and we're good. Done. We could now have a thing in here which is current state. This is going to return to me an I sub state, and make it public. We'll not make it a setter. So current state, and again this one. And again, this is only a convention I follow. If you want to have a convention, let's just go somewhat off-piste. Object org and coding guide. So Mobject is just a library that I maintain. You've got my coding convention here. So everything you see now, this is what I follow. If you want a coding convention, feel free to use mine. So anytime that I have a variable that matches an external property, you're not allowed it. So so this one here, so I want to maintain what the current state is. If I did that, that would fail, because it says that you match a property name. You're not allowed to do that, so it's already defined in the application suite, in the application substate. So what I do is then put an underscore in there. I know some people use underscores for all sort of private variables, but I don't like that. It's, again, anything that detracts the eye and it throws my reading ability. I don't like it, because I feel that you've only got so many slots for doing clever things in your head. If you're using them up by taking things like Hungarian notation or underscores and things like that, it just gets in the way. So there's probably a lot more people who've got a lot more sort of clever spaces in their head. I have to keep mine fairly clear, and I do that by making code a little bit easier to read. So when I see these things, I know that I match. And quite often, you're calling it the same thing because it is the same thing. Call it what it is. It's current state. And I can request out of it what is the current state. So now I can do current state. State is equal to underscore current state. Done. And we're good. The other thing that we want to do is we'll initialize. So this current state and initial substate, we know that when the thing initializes, current state will be the initial substate. That's just one of those things. Because again, you got to be a bit careful with interfaces. If you access an uninstantiated, it's not uninstantiated, an interface that hasn't been filled with someone, you get a memory exception. It's just the way of it. Yeah, it's just the way of it. So during instantiation, I'm going to make my initial substate the current state as well. Makes sense. Okay. Again, if I was doing this for real, now comes a TC unit test. So I would now say my application state dot current state. Again, it's property. I can go straight onto this. I don't tend to chain. I would put this into a variable first, then interrogate it. But there's nothing wrong with me doing this. This will work. Is equal. I'm going to say initial substate 2 because I've instantiated with initial substate. But I'm checking it with this one. They are the same state. It's an object that represents a state, and they're individual, as in they're the same. They're the same thing. In the same way, it's as if I've defined the enumeration twice. I'm saying, hey, are you this enumeration? Nice. I'm just going to make that one equal to test 2 and get rid of this one for the time being. Done. And save. Build. But this would be a test. And the test would be, does the application state return the current state when initialized as the thing you passed in an initial state, does it equal the current state when initialized? Done. Nice, easy check. It's something you want. If it breaks, you want to know about it. Log in with download. Play. Nice. All working. So far, so good. Okay, so we're on our way. So we now got this notion of these are representing our enumerations. This thing here is representing the thing that will be passed in to our module. And the module will say, hey, application state, your current state, do you equal the state I know that I react to? Done. Okay. Okay, we'll just, oh, hey, let's just log out and then I'll get access to the right thing. So what I'm going to do now is I'm just going to make one for modules, just so we can sort of mock out just that little bit. I hope this isn't going to be a too long video. So I feel that we're almost at the crunch point now. I'm just going to get rid of that. Because again, modules can be completely independent now, as in I'm not forcing them into like you need to know too much. At the moment, the only things that they're going to need is this notion of substates and application states. The other thing as well I am going to do is application substate. For it to have this current state, I'm just going to jump forward because I know things that I'm going to need. Things I'm going to need is get state. You could argue that current state is the same as do step, so the method do step is absolutely possible. So we could actually just use straight current state in the place of do step. I do feel that we would have one like move next, quite possibly. Move next, I would take more of a like a .NET approach and return boolean. So you can say move next and it will say true, I have something to do next. If it comes back and says move next false, you know you can jump out, you're done. There's no more states to talk about, that type of thing. I might also introduce the null pattern in a minute as well, just add a bit of safety. So, but anyway, so move next, let's just give a move next. This thing takes no inputs, and we'll do a bit of logic in here. The other thing as well I want to do is I'm going to have one register add state. Yeah, add state. Yeah, I think that's going to be a valid thing. So add state, it's not going to return anything, it's also going to be public. Because we know that the application itself has a predefined set of states that is known by the application. And that application state, or that application set of states, is different against all of your applications. So I'm going to have the ability to add a state, and this is going to be, add state, add substate, insert add state. I'm kind of tempted to write add substate, but let's just leave it as this add state. Yeah, call it what it is. Absolutely call it what it is. So, all right, it's an application substate. Add substate. Okay, I'll just okay that one now. Yeah, add substate, and the thing that you're going to pass in is the substate, and this is going to be I substate. Done. Done. Nice. So we can do a little bit of logic in here. So the first thing we're going to do is say if again, do we need a constructor? I would say this gives us safety by saying give me the initial state to start with. Feels kind of safe. We don't need to. We could actually do this all at when the thing starts up. We just add the states afterwards. Yeah, I'm kind of tempted to go that route. It works the same no matter what anyway. So this thing here has definitely received a I substate at this point here. So anytime that we do I substate, normally I would check, because if let's say for example we don't instantiate this thing with a substate, and we just say no, don't worry, I'll start empty, and you just add as you like. We would have to check to see if initial state and current state have actually got something inside them. So this add substate, because I'd say if the initial state is empty, make substate equal initial state, make current state equal initial state. That's where I'd do the check. But because we know we've instantiated it with a state, yeah, we can kind of skip that step. The next piece of the puzzle, and this is where we're going next, is I'm going to make substates know who comes next. It's going to be them that hold the next substate. So I'm actually going to make technically a linked list. So because it makes sense, it prevents us needing arrays. It's really nice and easy the way it flows. Everything about it, it screams out linked list. The only issue you would you get any issues? No, there's no issues with this. So being the notion of being able to hold who's next feels great to go into base class, because that means none of your child classes need to know about this. All they have to worry about is just tell me what their name is. Done. That's it. That's all you have to do. Base class does everything else. So the base class, I'm going to add a method in here, and I'm going to call set next. Set next. I could do set next. I could also make this a property. So set next. Yeah, that's kind of valid. To save time, because all I'm doing is requesting and getting who's next, I'm just going to make it a property, because I'm not taking any action upon it. I'm just holding it as a thing. So I'm going to do it as a property. So typically I use methods if it's going to do an action on a thing, or I use a try. So a try notation is try set state, and I might set the state and return true if I did it, that type of thing. So in this instance here, I'm literally going to hold who's next. So I may as well make it just a public property. So the next, it's a substate next. I'm just going to call it next for simplicity. I substate, it returns as substate, and it's going to be public, and it's going to be a getter and a setter. Now again, this thing here, this is going to have a next I substate, and if I get, then it's so next is equal to next, and if I set it, then I say next is equal to next. Oops, done. You can see again why I had to use the underscore, because it matched. There we go. So now when we say add substate, we know that something is already in the initial state, and we know something's in the current state. We can ignore current state for the time being, because that's what the application is going to use to know where it's progressing. So now what we're saying is I want to add a substate. So I can now say let's think. We will do a while loop. So we can say while initial, so we need a variable to hold this, because what we're going to do is we're going to make our way down the chain of all of the states, and we're going to stick it at the end. We could make this a double linked list, which means that we could hold reference to the tail, and then all we do is say, hey tail, add this at the end, and then remake the tail, as in re-identify the tail. I'm just going to while loop over it. So I'm going to make a variable, and it's going to be the I don't want to call it current, so I'm just going to call it because I'm using current state already. Current state. It doesn't matter. I will use. I don't want it to. It's underscore. So let's just go with this for the minute. Actually, current state. I'm going to call this current substate. Nice. That's it. So the current substate is an I substate. And it looks like a little bit of coding, but it's not. It's very simple coding, and once you've written this, you never need to touch it again. It's so flexible that you stick this in the library and you're done. All you have to do is just keep making loads of these, and then instantiate your application substate at the start. And what's nice too is you'll be able to do this from a CSV file, you'll be able to do this from JSON. Everything is possible at this point. So anyway, let's carry on. Let's try and get this done. So what I'm going to say is my current substate is going to be equal to my initial, because that's the head. Done. And then, sorry, that's done. Initial substate. Right, so current substate is equals that. So I'm going to say while the current substate dot net. Sorry, and again we've got to make that available. So next is going to be part of the interface. Paste that in, and again you just that's it. There's nothing inside these anyway, so that's all good. Right, so back to our add substate. So we're saying while the current substate dot next is anything other than 0. Do so. In other words, is there something in next? Then what we say is the one that I'm now currently looking at, current substate, is going to be equal to current substate dot next. So in other words, go to make current substate the one that was next, and round we go. So I'm going to now do that again. So by the time I drop out this while loop, when next is equal to 0, I drop out. And I now know that the current substate is the last in the list. And I can now say next is equal to the one that I'm passing in. And that's it. I've just attached that state. Oops. Just attach that state to the end of the list. Done. Nice. Next what we'll do. Because we may as well flesh the rest of this out, is the move next. What this is going to do is point current state at the one that is next in the list. So how do we do that? So, and again, we return true or false if it's possible. So what we're going to say is if the current state, and again, that's going to use its property, or we can use, it doesn't matter, we can use the internal one. If the current state, oops, dot next. So if there's something in there, so if the current state dot next equals 0, which means there's no one there, we've reached the end, then return. And what happens there is current state will remain the same. The Boolean will go false because it will naturally just drop out. And we're done. Move next. No, you can't. We're done. We've reached the end. Otherwise, if we get to this line, it means we're safe. There is something in next. So we can now say current state is equal to current state dot next. Done. And we return true because yes, there is a move next. There was something. And people can use that in an if statement now because they can say if move next. If it's true, you know you've got another state to go. Whether or not you need that in your application or not, I don't know. But again, that's what I do because you may as well return something true because you can if statement over it. Done. So as long as I've not got any issues here, we'll see if that works. This would be another time to use the wonderful Jacob's TC unit to do the test upon it. And what we're going to do now is we're going to do some initialization. So I'm going to say right at the very start, init, it's Boolean, and okay, so we're going to say if not init, then we're going to start doing some stuff. So application state, I'm definitely leaning now towards not instantiating it with initial state because I might want to defer that to a bit later anyway. Maybe I've got to do a few things before I even know what states I actually want, that type of thing. So so it's not going to be too much of a jump. You're not going to see too much more code in here. I'm actually going to take that out of this, and therefore this is going to be I want my initial, and then I'm going to add the application substate of let's not add the spaces of the power substate, that type of thing. Done. So that's how I'm going to actually instantiate this. I'm not going to do it by the constructor. So things we will need to do then instead. I'm just going to copy that out, delete this, no constructor anymore. All it does is it just means that this add substate is there's two things we need to do. So the first thing we will say if the initial substate is equal to 0, then we know that it's not been instantiated. This thing's not ready yet. So we can be very, very easy. We can say that the, let's just place that back in. Oops. So we can say the initial substate and the current substate and the current state are both this. Done. And we return out. Good. So at that point there, we know that if we get to this level, then the current substate is going to, this is this iterator one. So make it equal the initial. If next is non-zero, keep progressing down the list. And then when we reach the end, the dot next is now equal to the substate we've passed in. So that should be that. The other thing I want to do is I'm going to introduce a null object pattern, because one of the things you'll find is if I call upon this, actually init is not an issue. If I call upon this, application current state is equal. If I haven't run this code yet, there will be no substate inside of it, which means this will be a memory exception. Done. So a way of combating that is by using the null object pattern. Highly recommend it. You may as well. It's easy to implement and it's tidy. So what this will be is there will be, I'm just going to, so these substates, so this one here, this is going to be my null substate. And null is absolutely nothing. As in it represents an object, but the object is nothing. It's as nothing as it can be. So I would say that its name, if asked its name, it returns nothing. And the other thing I'm going to do is equal. I'm going to paste that in. And the minute I paste that in as a child, I take over that method. So I've now overridden the method. And because I'm null, even if you compare a null with a null, they're not the same. They're just no. I'm a no. Anything you ask me. So this one, I'm overriding what the base does and says, oops, there we go. So it doesn't matter what you ask of me, I'm no, but I'm safe. Everything about me is safe. And what I can do now is in this application substate, I can instantiate a null state. And so we will actually have to change our logic slightly again. Sorry, I'm not going to do it there. I will have this null substate, but I'm not going to, because sometimes you can actually pre-initialize these to know it, to say, oh, I'll start off as null. But then that makes checking our, are we initialized? Oops, what have I got wrong? There we go. Okay, yeah, I could assign them straight underneath there, but then it makes our check to say, have we been initialized? A little bit harder because I can't check for null, that type of thing. So what I'm actually going to do is in here, in the getter of current state, I can do a check here. So I'm going to say if current state, and sorry, that's the underscore. So if current state is equal to nothing, as in it's not been instantiated, then I'm going to return out current state is equal to null substate. Done. You're going to get one of them. And we return out. Done. This is a nice way of programming as well. If you do the whole negative side things first, it means that you don't end up with these massive if statements that just go on forever. Do something, get out. If you're in a positive path and you're progressing well, you continue underneath, and it just means all your code stays right up against the left-hand side. Okay, right, almost there. We're almost at the end. Right, so current state, this is our null substate is going to get returned, which means now, even if this isn't called, this will be fine. It will return false, but it's fine. We won't get a memory set exception. So I'm actually going to, let's just comment that out. Let's just make sure I'm not going to pop. I don't think there's anything that's an issue, which is fine. So that, had we not done the null object pattern, that would have failed at that point. That would have given us a memory exception saying there is nothing under the memory location 0. And we can see there it's, yeah, init substate 2 is not equal to null. Yeah, it returns false regardless. It absolutely returns false regardless. Right, so let's put in our initialization of this now. Highly recommend getting a mouse that's got, the ones that come with forwards and back. And they assign it to forwards and back. Whoever uses forwards and back on a web page with your mouse, I mean, apologies if you do. Reassign them to copy paste. Love it. I know you meant to use keyboard all the time, and you don't get copy paste errors if you don't copy paste. But copy paste on your mouse is so good. And mine's next level up. That if I hold another button on there, my copy paste becomes comment uncomment. You'll never go back. It's so good. Even though it is, I think it's Control K, Control C and Control K, Control U, but again, who presses those buttons? Right, so now I'm saying add the substate of init, add the substate of axis power substate, good. We would now be saying the first test we're going to do, and again, I'm going to do this all under an init because I only want it to run once. So this one here is going to be init is equal to true, just so we can see the results. So the current state, I just want to make sure, so what I'm testing now, and again this would have been the test, I want to make sure that the current state, when I first initialize, the current state is equal to init. So again, these aren't helping us, these ones. So is init, I'm going to call it this because then we can actually see it, has next, and I'm going to have is power. Right, there we go. That's looking better. So that is power. That needs to be this one here, and the thing that's in the middle, has next, will be is equal to application state dot move next. As in, I'm asking it, can you move next? So we should get has next go true. And this, as you can see, this is why I want to only do it the once. Otherwise, it'll rattle through to the end. It will rattle through to the end. It'll just upset our Boolean state, so it make it a little bit harder for us to see. And I think we're there. Good, done. Build. That built okay. Login with download. I tend to do login with download most of the times. Good. So there we go. Isn't it? Yes, it was. Has next? Yes, it did. Is power the next one? Yes, it is. Good. It followed the order that was here. So far, so good. So what we've done is we've successfully replaced the need for an enumeration so far. Your application state, so where you was originally defining your enumeration and making it custom to your application, becomes no more than writing this at the start of your program. Now, the next level up, the bit that makes this then really powerful, that you go, well, actually this helps out, is if I make application state also implement an interface of application state. And I don't want to expose add substate to it. That's something, no. When I pass it to someone, you use my state, you don't affect what's in me. You can ask move next, or you can get my current state. That's all I want it to be in the interface. And the reason is because I might in the future make a application state from file, application state from MQTT, those types of things. Anything could be application state. As long as it implements current state and move next, I might even, let's just add one more, because I think there's one more that's probably worthwhile. I'm going to have one called reset. It will always reset because it does, because that's just one of those things it can do, reset. Rest. Nice, just refactor that. So if I call upon it reset, we know that the initial substate, we hold that. So we do nothing more than say that the current state, and that's underscore, current state is going to be equal to initial substate. Done. That's all we do. That's what happens on the reset. Whether or not we want people outside to have the ability to just straight up call reset upon it, it's kind of up to you at this point. We're now starting to get into the intricacies of what you want to do in your actual program itself. There we go. So anyone now can have an application state given to them, and they won't know what type of application state thing it is. In ours, it's just a linked list that's containing all of the substates themselves. And when it iterates across them, it uses the next of the substate itself. You may have something completely different. You may give it something that picks at random what state it is. It might use the values from a machine to determine what state is, that type of thing. So yeah, you can see as well that we're not, as much as we know next, we've built next in on the substate. You may turn around and say, no, I even want to hide away that next. I just want my substates to be is equal and name. Maybe that's all you want to have. So, but again, I'm just showing you a route. Right, anyway, so that's my reset. Again, you would write a test. I love tests. Right, so is back to init. Is back to init. Because again, once you've written a test, it is just in there, and every time you download and do it again, it just retests your code. It's the perfect way. Write your tests. So we now know that we can say reset on this, and we should get is back to init. Come back. Going download. Play. All good. So yeah, that's working. And you can see objects. Okay, don't get me wrong. It's taken me a while to write this. Blah blah blah. But this is solid, and there is no code in any of this. And you'll see that it's not fragile in the slightest, because people can just go off now and do their own thing. The only thing people need to have in a shared library is iSubstate, and they can join the party. So because anyone who's an iSubstate will be accepted in that method call, and then the minute you say move next, move next, move next, you just keep getting them. That's that type of thing. And lastly, let me just complete it. So we'll say this is the access module. This one I will use constructor. So because I feel that an access module, and there'll be a couple of things we can do in the we can go more steps further. I mean, everything's possible at this point. So this access module is going to have a current. It will have an application state. You could pass it in on a method, but I feel it's acceptable for these things. Because the modules themselves are so dependent. Don't get me wrong. The initial take on this was go the state machine pattern, lift the functionality out, put it in objects, let those objects be the code. We don't have to go that route. This is a way of saying, no, I still want my modules to determine what they do. I code what's inside my module, what they do, based on state changing. This is why I've gone down this route. This isn't a pattern. There is, but in the same way, and I think I said this at the start, same way they say object-oriented patterns are available. They are. They're a tool. Most of the code I write is not a pattern. It's a very custom bit of code that I wrote that allows me to do very objecty things. Almost always I'm doing dependency inversion, which is because I'm using interfaces everywhere. I can just go have one of those. I'll care about what it is later. But you don't have to write OOP code as a pattern. The suggestions of how to solve common problems, you can just write your own objects. Same as PackML. I find the same with PackML. PackML, great for that top level machine layer when you say, hey, I don't even care what you are as a machine. Hey, getting on. Can you start? Can you stop? This type of thing. Very generic. You allow very generic machines to talk to each other. You find people get a bit stuck when they start going, we'll bring PackML down every layer. Even PackML say you can do this. Just keep dropping it down a layer and saying, hey, my drive could be a PackML state machine. Should it? I don't know. Because suddenly you find yourself going, what's like the holding state of a like a motor's drive? You end up so abstract. You've tried to put an abstract concept as something that's going to work across everything into something that's very specific. You do better just having local enumerations, monitoring state. Ask it to enable, disable. That's fine. So yeah, don't feel you have to implement patterns. And this definitely is going off the beaten track. This one, but it's going to work. So yeah. Anyway, sorry, there was a digression as well. But that's coding bytes for you. Right, last bit. Constructor. Sorry, when I talk, then I lose it. It's constructor. Just let my fingers do it. If you haven't already learned to touch type, I highly recommend it as well. Just learn it. It takes about. It took me 3 months, because you keep drifting back, and but stick with it, and then you don't need to look at your keyboard. Just do your thing. So highly recommend it. So this thing here is going to say I'm going to do the whole thing of I pass in an application state, because like I say, this module has been designed to know someone's going to give it state. Yeah. So I've coupled it to it needs to know what the application state is. Again, because it's called the same thing, you have to tell it this dot application state. So application state is this. What's nice about this is we construct it, which means you will have one. Don't worry about it, you will have one. And then if I'll just do an execute, execute, and this is how I would then use it. So this has got an execute method. It would have a variable, and we would say init state is an init. And I'd call that, again, most of the time I call things exactly the same, which you're allowed to do. That's not an issue. So this one's going to respond to the init state, and what was the other one called? Axis power substate. Nice. Yep, so it's going to have these two. Nice. And then I would say if, and again, that notion of there was calling a method originally called doStep, I think it was, but again, it's fine. This is a different take. So where am I? Oops, back in here. So if the application state dot current state is equal to the initialization one, then do what I do to init. And then it's here that you would maybe it's the application state here that you would do something along the lines of request next state, that type of thing, or or I mean, in our instance, it's called move next because we're kind of forcing the application to move next. That's just why I've coded it. You may not want that. You may say no. The application state you request for it to move next, or it does, or it waits until all the other ones have done it, that type of thing. But whatever it is, you'll be asking it to do something here, which will be some form of changing state. We've already proved that move next works. I might as well put it in there because move next. That's it. It will naturally make the thing move next. The other thing as well, I suppose you have to be a little bit careful of, is the minute we go move next and we call upon that straight away, you would do that as an if else, because otherwise you won't get a PLC cycle in between. It's else if, which is this. Not a big fan of else ifs, but it's a case statement when you're using Boolean. Yeah, had you wanted to keep it as an as a number, so you could use it in a case, then you would be adding to this I substate a number that represents it, something that can be used in a switch case statement. And then you can do, you would do something along the lines of current state. Again, this is only mocked now, so case of this thing would be its like its ID or whatever you want to class it as. And then here you still wouldn't make anyone know what that is. You would do that instead. So that's if you wanted to still use like a case statement instead. You would just have to, instead of forcing people to use a name, maybe you make them implement a name and an ID, and then you can use that instead. So absolutely valid. Or you use the but you can see here, like an enumeration, I never expose the actual value that's underneath the hood, because you don't want to do that. You don't want to have these magic numbers that are kicking around, all those type of things. So so yeah, as long as this is the same as this, yeah, I'm good to go. And these are the ones that I abide by, and that's that. And this is what I do if it's power on, and that's the axis power substate. So if it's equal to that, we do this. If not, we do that. Done. And then the last piece of the puzzle, which is if this one was solenoid extend substate. I should have just followed what was actually on the original one, but anyway, this one's going to have sol extend again. Don't abbreviate. If you don't need to, don't abbreviate. It's using up those spots in your head. Intelligent spot in my head got used up by trying to complete sol into solenoid. There's no need. So, and then this one here. So therefore, if we had the access module or we had the pusher module, and that's that. And it has an execute, and this thing instead, it only cares about this one, pusher module, which is that and that. Oops, that side done, that Good. You can see here they're both conflicting with each other in terms of they're both asking to move next. But again, whatever we want to do. I'm just going to comment those out for the time being anyway. But you can see here how the move next. Well, actually, I suppose that doesn't cause too much of an issue. All right, the init, both of them would ask to move next, which would actually jump it twice. You could quite happily keep that there. Oops. Because it's only this one that's ever going to know that that state exists, and it's the only one that's going to move it forward. So, and let's just put the last pieces of this puzzle together, and then we'll call it a day with the video. So this one here. So now all of a sudden we've come along and we said, hey, so you can see. So let's just roll through that. The pusher module itself, it wanted to know this init substate. It also had this notion of a solenoid extend substate. In the library that you share to people will be iSubstate, because that's what these things, if I want to make my own version of it, I'll have to expose substate because this thing extends upon it, and iSubstate will be in there as well, just because it's its interface. So this will be in your library, your common library. You will then put your common states in here as well. So your common states will be things like init substate. So that lives in the common library, which means when you're developing in isolation your pusher module, you can then say, yeah, the pusher module knows this init substate because I use that common library. I also make my own version of this library, which is specifically for this module. I've got this substate, only it needs to know about it. We're all good, because my initial library never needs to know about it. The Axis module doesn't need to know about that state. No one cares. And it's only when you bring these libraries into your final project in here that in order to write those 3 lines, you're going to need the common library, your Axis library, and your solenoid library, or your pusher library. And then you build it. And that's it. So now I can say, well, actually I want to do the solenoid first before I turn the power on. We're done. And then the final part, let's just put these in. So the Axis module is an Axis module, and it takes an application state because it's an I application state, and it's going to complain because I always forget to implement it. Implements. I application state. Done. Back to main. So this one here, this module, application state is done, and then we'll also have the opposite, which is our pusher module. Pusher module, pusher module, pusher module. Good. Now both of these would be allowed to do an execute. Pusher module, execute. Nice. So when it starts off, it will be in init. Execute will have caused it to init anyway. By the time it reaches the pusher module, it will be in the next state, which means it will be solenoid extend substate, should be. And then it'll ask it to move on. And then the final thing it'll do is it'll sit in this Axis power substate. And because I'm not going to run that again, it'll just sit there at that point. So we could as well, Axis part, we can just do that under here, because that should be right. So we're checking it out. This will fail because move next. Just need to put that in there because it will now go init solenoid power. So init move next power, move next. Init power. Then we reset it. We check it goes back to init, and then we execute this Axis module, which is going to do. It is equal to this because I've just declared another object the same, and it's the same thing. It's as if I've just said, no, here's the common state that we all hold. If it's equal, it'll ask it to move next. Then this one will fire. It won't be equal to init anymore because it'll be this one. It'll ask it to move next, and then the final if we were to have called it, it'll move next again, but I'm not going to call it, which means it should be still sitting on this axis power substate. Although it won't move off of it anyway, because if you try to move next, it won't move next, so it will still be on that off anyway. We'll give it a go, just make sure nothing... application substate must be... Oh, that's because... application... I've called it application state. And in here, I called it application substate. Let's just copy that across, and this one. Nice. This one, application state. That's good. Nice. We'll download. Play. Main. Is power is true. So yeah, it all worked as we expected it. I've got full control now over what states occur when. I've passed an object into people that don't care like what it is. All right, it's my version of it, which is allows me to just do it by instantiation or by methods, just build my thing. Yeah, the world's my oyster at this point. Completely valid. The very, very final thing I'm just going to show you, absolute final. If you've made it this far, hats off to you. This axis module here, would you even, let's say for example, we want to say, well, no, I want to decide what the init state is, and I want to decide what the power on state is as well. You can defer that too. You can make that external. So this module here, at the moment we're saying, hey, do you equal this init substate and this power substate? We've hard coded that inside. What we could do is say, well, this is the module init substate, and this is the module axis, and maybe init, yeah, it still reads right. I'm going to call that an I substate. Okay, so this now, we put that in here. I called it the same thing as that, so that's that, capital A, and I get rid of these local ones. Done. So now I'm actually saying, if you equal the thing that I'm going to define later, move next, and if you equal this, move next. And in here, I would now say, what's my init state, which is, let's just copy these across again. I'll call them slightly different this time, so we don't have to use this. So that and that. And the module version is going to be equal to this one, oops, this one, and that's an equals. Good, nice. Yeah, now we define, now we've actually, we've inverted the dependency on what even the states that this module needs to use. So we can now say in main, just up here, just going to paste those just so I don't have to write them. So we don't even need to declare what these things are. I mean, the minute I get more than one argument, I do, because it makes it easier to read. You can mix and match as well, you don't have to. It's just if you lay it out in the same order that they appear, then that's fine. So this thing here, application state, I'll leave that as is. Now I can say, well, actually, no. Like if I was doing it for real, obviously that would be this, and that would be that. Done. So I've now instantiated my axis module. Not only have I passed it in someone who's going to tell it its state, I'm also passing in the states that I want it to react upon. There you go, nice and flexible. Don't know if you'd ever want to do that, but it's absolutely fine to do. That's completely valid. And now if you say, well, actually, I'd prefer it if it did the power on when this state came in instead. It's done. Too easy. Okay. That was slightly longer than what I was expecting. I hope that helped. I hope I got the right end of the stick. Otherwise, this was a bit of a weird journey through your problem. A bit of a different coding Bytes. Let me know if you like it. And then obviously I can do other ones as well. All right. See you in the next one.